Hi and welcome to this Junior Cycle Higher Level Maths video where we're revising scientific notation, otherwise known as standard notation. So as part of this, we're going to be identifying scientific notation, we're going to be converting scientific notation to decimal form, converting to scientific notation, decimal form to scientific notation, and finally some distance, speed and time problems in standard form. Scientific notation, which is also known as standard form, is a special way of writing numbers. So here's two examples. 700 is a number, and in scientific notation, this is 7 by 10 to the power of 2. The second number here, that's 4,900,000,000, that can be written as 4.9 by 10 to the power of 9. So what this does is it makes it very easy to deal with really big numbers or very small numbers. They are common numbers, so if we think of it as standard means the same. So this will be the same form written across the world. Okay, it's used a lot in science, and that's why it's known as scientific notation. Be aware you can get questions, might say scientific notation, it might say standard form or standard notation, or it may give you the form that looks like by 10 to a power of. So here it also saves space. Here's what happened when you double each square on the chessboard. This is an exponential sequence. We have 1 and then double it 2. By 2 is 4, by 2 is 8. Now, what happens when we have an exponential sequence is it grows, if you've ever heard the word, exponentially, so very quickly. And the numbers get very big. So we wouldn't be able to fit all those on our nice little chess square. But if we use this scientific notation, we can. So the very last number, 9 by 10 to the power of 18, that's huge. It's actually this number here down the bottom that I'm now going to try pronounce, but we can round it first of all and create something that's much neater to work with. So that's just from Maths is Fun. If you want to check them out, great website. So here is something written in scientific notation. We have the first number, which should be between 1 and 10. It should only be one digit before the decimal point, so it does not include 10. It can be 1, so 1 point something up to 9.9. It's then multiplied by 10 to a power. That power n should be an integer. An integer is a positive or negative whole number. So here's some examples. We have 8 million here, so that is 8 by 10 to the power of 6. And here we have 0.000008, which is 8 by 10 to the power of minus 6. So here's our first introduction to big numbers and small numbers. Big numbers have a power that's positive. Small numbers, i.e. decimals, are going to have a power that's negative. So let's look at an example. Identifying standard form or scientific notation. Which of the following numbers is written in standard form? So this first one, yes, because we have a number between 1 and 10 by 10 to a power. Second one, no, because it's 14.3. If we wanted to write this, it would have to be written as 1.43. And because we have made this number smaller, we need to then increase our power to the power of 5 to keep it the same number. Our third one here is not scientific notation or standard form because our number is smaller than 1. If we wanted to write that correctly, we would have to turn this to an 8, which would mean making this bigger, which would mean then taking 1 away from our power here because it'd be 10 to the power of 2, which will give us then the same number. Power 4 is incorrect. Standard form. 9.8 is less than 10 and by 10 to a power. Example 2, write each of the following as decimal numbers. So we're going to get rid of that by 10 to a power of. So this is 6 multiplied by 10 to the power of 2. Now, the power of 2 says we're going to jump the decimal place 2 spaces to the right. That's our shortcut for multiplying by tens, hundreds, thousands, so any 10 to a power of. So my final answer is 600. 4.5, just to help, I just add in a few zeros to do the jump. I'm going to do 2 jumps. There's 1, there's 2, and we have 450. Just be careful. When you were in primary school and maybe even first year, you might have learned about the idea of multiply by 10, put a 0 on the end. That's not necessarily true. It is moving the decimal point. If you just add zeros to the end, you could end up with an incorrect answer. Part 2 here is an example of that. If you added 2 zeros onto the end, because it's 10 to the power of 2, we'd end up with 4,500, which is a very different answer to our 450. Now we have a negative power. Remember, the negative power means the number is smaller. So to help, I'm going to put some zeros before the 4. Because it was -3, I'm going to end up making my decimal number smaller. So I jump it 3 spaces to the left. So I get 0.0048. My final one here is 9.2 to the power of -4. So again, we're making this smaller. I've put in some zeros. 1, 2, 3, 4. So I end up with 0.00092. So it's all about moving our decimal point to the left and to the right. So example 3, converting to standard form. Express these numbers in standard form. At first glance, they may look like standard form, but they're not, because remember, our number, the first part, must be between 1 and 10, and it cannot equal 10. So this is 4 by 10 to the power of. I've divided 40 by 10, so I've moved its decimal place over here, which means to counteract that, I'm going to have to make this 10 part bigger, because I've made the first part smaller. I'll make it bigger by adding 1 onto the power. Here, we're going to have to move it 2 decimal places to make it a number that's between 1 and 10. Because I've moved it 2 places, so I've made it smaller by power 2, to counteract that, I'm going to have to increase the power here to a power 5. Now, what if we work the other way? So in part 3, 0.9 is too small. I need to make it bigger. So I'm going to move my decimal place to the right. Because I made this bigger by 1 power, I'm going to need to reduce the power here on my 10 to counteract it. So it's 9 by 10 to the power of 2. My final one here, I bring my decimal place 1 space to the left. I'm making this smaller, which means I'm going to make my 10 to the power bigger by power 1. So it's 10 to the power of 3. So it's really about increasing the power when you've made the first number smaller, and when you've made the first number bigger, reducing the power on the 10. So now let's convert from decimal form to standard form. Let's write each of these in standard form. So first thing I do is I find my decimal place and I jump it back. In this case, 2 spaces until I have a number that's between 1 and 10. And remember, it can't equal 10. So this is 4 by 10 to the power of. Because it was a bigger number, my power is going to be positive, so it's going to be 10 to the power of 2. Here, I move my decimal point 2 places to the right. So I started with a smaller number, so that means my power here is going to be negative, so it's negative 2 spaces that we jumped. Here, 1, 2, 3, so we get 7. Remember that this was a smaller number, so it's going to have a minus power, so it's to the power of minus 3. Part IV, 1, 2, 3. So we end up with 6.5 by 10 to the power of minus 3. And our final one, the decimal point, is always here at the end. And we jump it back 3 places, which gives us 8.6 by 10 to the power of 3. Remember, when we start with a bigger number, then our power is positive. When we start with a smaller number, our power is negative. Our final question is more of a problem-solving question, and these were very typical on the junior certificate paper. We've yet to see if these are the type of questions we might see on the junior cycle paper. The closest star to our sun is Proxima Centauri. It is this many, which is a lot many, meters away from the Earth. Write this distance in standard form. So you can see, now if you are anything like me, I'm very honest about this, a lot of digits will confuse me. In this case, I would have to have commas to help me. So if you need to put in commas, I hate working in decimals because I always lose my places. So I much prefer standard form or scientific notation because I struggle when there is a lot of digits. So I'm going to do some jumps. Now, to make this easier, I'm going to do 3, so jumps 3 at a time. 3, 6, 9, 12, 15, and then one more, 16. So this ends up as 4 by 10 to the power of 16. There was 16 jumps. The number was very big to begin with, so my power would be big. Sorry, would be positive. The second part of this question gives us the speed of light. So light travels at a speed of 3 by 10 to the power of 8 meters per second. How many seconds does it take for the light to travel from this star to Earth? Give your answer in standard form, correct to 1 decimal place. So the first thing I'm going to do, I'm doing my little DST triangle. So we have distance, which is, I should have wrote in meters. We have speed, and we're looking for time. So time is distance divided by speed. So time equals distance divided by speed. So to work out the time, we have distance, which is 4 by 10 to the power of 16, over speed, which is 3 by 10 to the power of 8. Now, you can use your calculator. That's fine. But we can actually do this without the calculator. So I'm going to focus on these bits here first. I have a 10 to the power of 16 on the top and a 10 to the power of 8 on the bottom. You need to make sure that you know your rules of indices, and they're in your log tables. So if you would like to just pause and go get your log tables, do. And make sure you've already revised your rules of indices before looking at this. So I'm on page 21, and I have something to a power divided by something to a power. This is the second law. It is a to the power of p over a to the power of q is a to the power of p minus q. So we'll have 10 to the power of 16 minus 8, which will be at 10 to the power of 8. So we have 4 over 3 by 10 to the power of 8. Now, the reason I'm allowed to do that multiplication is because multiplication and division are the opposites of each other. So we can split this out whatever way we wanted to. You can now figure out that 4 over 3 is 1 1/3. So that gives me 1.3, correct to 1 decimal place, by 10 to the power of 8. So that is absolutely fine to do in your head. Now, are you going to do it in your head? Probably not. So let's talk through how we'll do it on the calculator. So the first thing I'm going to do on my calculator is I'm going to put in the fraction button. I then have 4. Depending on your type of calculator, I'm going to talk Casio first. The very bottom row of buttons, the middle one is by 10 and a little X on top. So I press that button and I get multiply by 10. Now you just type 16. You don't have to write powers or anything because that's taken into account with that button. So it's 4. You press that button. It's right beside the ANS button and you write 16. Then it's 3. Again, press that button and 8. Can you multiply by 10 and do your power button? Yeah, but that's extra time. Why bother? Now, if you do it that way, depending on how your calculator is currently set up, you'll probably get your answer in decimal and you'll probably have to work back then to standard form. I got 133333383.3 and you'd need to work backwards then. If you're using a sharp calculator, there is an EXP button, and that EXP, when you press it, is the same as by 10 to a power of. Again, don't use your power button, just use EXP and then write 16, and on the bottom line, EXP and 8. It'll come up as an uppercase E that looks a little bit funny on your screen, and you should again get, I don't have my sharp here in front of me, but I think depending how it's set up, you may get it in decimal, you may get it in standard notation. If you don't and you get decimal, you'll just need to convert it yourself.